Hi, I'm Dr. Christy Sutton, and today we're going to be talking about detoxification, genomics, and epigenetics. So let's dive in. First, disclaimer, this is for educational purposes only and is not intended to diagnose, treat, or prevent disease. So if we're going to talk about detoxification, there's some kind of generic good advice that if you just want to kind of refine your recommendations down to a simple generic slide, it's still good advice. It's just let's start simple and then kind of expand on that, because it's nice to have the bullet points to give to patients or to kind of keep in mind while still learning about the little idiosyncrasies of detoxification so that you can really get sophisticated. So bullet points are, as far as promoting detoxification, add probiotics to your diet. We'll talk more about that in a second. Cut processed foods out of your diet. Get rid of all those bad oils and unrefined carbs and just all of the chemicals in food. Fast regularly so that your body can do autophagy and go and remove, increase detox pathways and remove cancer-causing cells and really kind of bring the garbage man in to clean house. Drink plenty of water, dilute, keep those kidneys healthy so that you can get stuff out. Sleep. A lot of the detoxification that occurs in your body, especially the part of the lymphatic system that detoxifies your brain, which is your lymphatic system, that largely happens while you sleep, when your body shuts down all of the other processes and it can really focus on cleaning house. Sweat regularly. We remove toxins through our skin, and sweat is one important way to do that. If you're not sweating, either because your body doesn't sweat or because you're just not putting it in a state so that it will sweat, then you're more likely to be unhealthy and have health problems. One of the common things that I see in really sick people is they just don't sweat. And if you can get them to sweat, then they will be healthier for it. Is often a different pathway for everybody as far as getting them to sweat. But in general, just getting them healthier will help them to be able to sweat more or really sweat at all. And not being able to sweat is a really dangerous thing because it's easy to overheat, and that can be, life-threatening. Minimize environmental exposures. That's getting harder and harder, but more and more important. We've got to get the toxins out of our house and our lives. Unfortunately, a lot of them are ubiquitous and hard to remove. So we have to also promote our detox pathways for the inevitable exposure that we're going to get. And of course, eat lots of fresh organic fruits and veggies, because this is, Mother Nature's detox foods, the foods that are really designed to help us to keep our liver healthy, support our detox pathways, make sure we have all those antioxidants, so get all the different colors of the rainbow. So those are the generic bullet points, good to keep in mind, but of course, that's not what you showed up to listen to me for. So let's look at the State of the Union. This is a nice little infographic showing the toxicity load of insecticide use in U.S. agriculture, which from 1992 to 2014 has had exponential growth and has continued that path. The primary insecticide that is being used in U.S. agriculture is neonicotinoids. I'm sorry if I mispronounced that, but these are a class of neurotoxic insecticides that don't just destroy insects' nervous systems, but they can also cause a lot of health problems in humans as well. And they are a big part of the bee collapse as far as the dramatic decrease in bee populations, which is a serious issue if you like to eat fruits and vegetables that need to be pollinated, which you do. So in humans, we found that the research shows that these same chemicals that are being used to kill insects will lower testosterone, alter insulin regulation, increasing your risk for diabetes, insulin resistance, change fat metabolism, and even create birth defects such as heart and brain deformations. So these are serious issues, and they're becoming more and more common in our population, in our environment. We are, as humans, the top of the food chain. And so here's some kind of images to help us understand what that means. If we look on the left here, you look at PCBs, which are, technically no longer supposed to be made or allowed, but they are still around and being used and in the environment. Part of that is because they have such a long half-life and take so long to break down. So this is just an example of one of many potential toxic chemicals that gets put into the air, get into our environment, gets eaten by the zooplankton and phytoplankton, which then, smaller fish eat the small zooplankton and phytoplankton and algae, and then the bigger fish eat the smaller fish, and then, the even bigger animals eat the big fish. Now you could insert a human here where this orca whale is, because we're the top of the food chain. We're the ones that are going to be getting the largest amount of these chemicals, simply because they build up slowly in each of these organisms. And with each, animal getting bigger, the accumulation increases. So this is why eating large fish like swordfish, tuna, is a higher risk for exposure to mercury. So if you look over here, you get some mercury in the water from industrial use, or maybe you just have mercury in your body because, you have mercury fillings. But in this case, the mercury comes from the environment, from the air. Basically, the mercury is coming from burning, and then industrialization. And so then the water, it gets in the water, and then it gets in the algae, and then the insects eat the algae, and then the insects eat the insects, and then the small fish eat the insects, and then the big fish eat the fish, and then the humans eat the fish. So we're the top of the food chain when it comes to being toxic. It's really naive to think that we are not toxic, because we are. Even if you don't eat animal products, like if you're a vegan or a vegetarian, you're still accumulating large amount of toxins simply because they are ubiquitous. So where does detoxification start? In the gut. It tricked you. I gave you a subconscious clue of the liver, but it's actually the gut. Liver is key for detoxification. However, it starts in the gut, and it starts largely with your gut microbiome. So here's a really great article to elaborate on, the importance of understanding how our gut microbiome is our first line of defense. And it's a really cool line of defense, because we can have all sorts of genetic issues where we don't detoxify chemicals correctly, but we can bypass a lot of those genetic SNPs, those detox genes that don't detoxify very well. We can bypass a lot of those just by having a really good gut microbiome, which is why, as we live in an increasingly toxic world where it's becoming, for many people, increasingly hard to have a healthy gut, it becomes all the more important to have a healthy gut, which is why we really need to make it a priority and fight for it, and not make bad decisions that allow it to go by the wayside, because it is our first line of defense. It is, where our immune system is going to be meeting the environment first, as far as what we eat. Of course, our skin is the outside layer, but our gut is the inside protection, and our gut microbiome is what keeps our gut lining healthy, but is also, it turns on good genes and turns off bad genes. If you have a healthy gut microbiome, it turns on bad genes and turns off good genes if you have an unhealthy microbiome, like dysbiosis, small intestinal bacterial overgrowth, etc. So here's what this article says. This article says that it just took some of the various toxins that were found in foods, and it looked at acrylamide. So acrylamide largely comes from roasting and baking and cooking food at a high temperature. And this creates a lot of oxidative stress, which ultimately can create toxicity in our body. Acrylamides are chemicals that are usually conjugated via the glutathione pathway. However, let's say you have an issue with the glutathione detox pathway. Well, probiotics actually have the capacity to reduce the damage created by eating acrylamide chemicals from your diet. So, of course, having plenty of glutathione, having good glutathione detox genes is wonderful. But even if you don't have those, which we'll talk more about having those and what that means and what to do about that. But even if you don't have the best glutathione genes, if you have really healthy gut microbiome, that's a great way to bypass those issues and protect yourself, because probiotics detoxify the acrylamides. They also detoxify the mycotoxins like alpha toxin, which is a serious carcinogen mutagen. And then this article goes on to say that among contaminants, mycotoxins, so toxins from molds, are probably the biggest threat to human health due to their high carcinogenesis. So because they cause cancer, they're so cancer causing, they cause so much DNA damage, they're probably the biggest threat to human health. And then it goes on to say, in addition, mycotoxins formed by certain kinds of fungi cause acute poisoning and significant deficits in the immune system. So it decreases your immune system, so you're more likely to get sick from other things, and it causes acute poisoning. And probiotics bind to these mycotoxins, and they protect the probiotics. They actually protect us from these mycotoxins. So then it also talks about how specifically lactobacillus, yeast, and the lactobacillus bacteria are very important for binding to mycotoxins and fighting alpha toxins specifically, which alpha toxins are extremely toxic and, as you might already know, are common on peanuts. Almost all peanuts, I think, have alpha toxins simply because it's virtually impossible not to. And the truth is the alpha toxins might be a big part of what is driving so many peanut allergies. And so here we're looking at a situation where the gut microbiome is protecting from the alpha toxin. Heavy metals. So there are heavy metals in our food, whether we like it or not. And probiotics can bind to the heavy metals and protect us from the heavy metals. They can also modulate the immune system so that the heavy metals are less of a problem. And they help us to poop out the heavy metals rather than absorbing them. Bifidobacterium, in this article, it says that they're linked to the ability to bind to toxic compounds. So the bacteria are able to bind to these toxic chemicals, heavy metals, mycotoxins, carcinogenic things, and remove them. And it goes on to say ochratoxin, which is a common mycotoxin. If you have Saccharomyces, like Saccharomyces boulardii, combined with anthocyanin. So anthocyanin is what's found in like red, purple, and blue fruits and vegetables. So if you have these good yeast and you give them good probiotics, which are the anthocyanin, this is going to feed the good yeast and feed the good bacteria, then you have the capacity to bind to the mycotoxins. So we're detoxing in the gut. We're not even letting them enter into the cells if we have a good, healthy microbiome. This is our first line of defense. And of course, then it goes on to talk about how the GI tract probiotics are important for breaking down carcinogenic compounds and making it so that our body can be better about apoptosis. So apoptosis is where your body says, okay, I'm going to sacrifice this cell and I'm going to have this cell commit suicide so that it doesn't go on to create cancer. And if we have a healthy gut microbiome, we're going to have less damage in the first place. So we're going to have fewer carcinogens creating DNA damage. But then whenever we do get DNA damage, we're going to be better about killing the cells so that they don't go on to spread and become cancer that kills us. So probiotics are definitely the first line of defense in the gut. And from this same article, it goes on to illustrate how our food has physical contaminants, whether it's metal chips, wood chips, shards of glass, dust particles, hair, nails, chemical contaminants, antibiotics, pesticides, chemical fertilizers, mycotoxins, toxins, and biological contaminants, pathogens, yeast, fungus, molds, viruses. That's all in our food. And if we have a healthy gut lining, then we're going to be we're going to be able to bind the carcinogenic compounds if we have good bacteria. And then if we have good bacteria, then that's going to make us have short-chain fatty acids like butyrate. Some people will supplement with butyrate to help support the gut lining, and that's a great way to kind of support a good gut microbiome. But also just taking prebiotics and probiotics is a great way to naturally make butyrate. But butyrate is going to feed your healthy gut lining cells, and it's also going to help to decrease damaged cells from carcinogenic compounds, and it's going to help to decrease cancer by helping damaged cells go under apoptosis. So here's another article talking about another contaminant called benzopyrene, which is the primary sources from our food supply, and how bifidobacteria and lactic acid bacteria like lactobacillus, these are good bacteria, have been used to study the elimination of these carcinogenic contaminants of food. And basically, they've concluded that these probiotic strains were highly efficient in the removal of this benzopyrene, also having no toxic effects and potential adverse health effects. So PAH, polycyclic aromatic hydrocarbons, is a common benzopyrene. So this comes from exhaust, fumes, cigarettes, cooking meat at a high temperature. We have natural detox pathways, phase 1 detox pathways like CYP1A1 and CYP1A2 that our body uses to detoxify these chemicals. But a lot of people have genetic issues where they don't detoxify as well. And even those people that have perfect genes for this, wouldn't it be nice to just decrease your total toxic burden by not even letting those chemicals get past your digestive system into your body? And the way to do that is with probiotics, healthy gut microbiome. That's where it starts. So again, fermented foods, probiotics with supplements, healthy gut microbiome. We're going to have short chain fatty acids like butyrate. If we have lots of probiotics, we're going to have healthy enzymes, nucleic acids like glutamine. Absorption is going to go up. We're just going to generally be healthier, and then we're going to have less mycotoxins, acrylamide, benzopyrene, heavy metals, mutagens that cause cancer. So it's our gut where it all starts as far as detox goes. And this slide I just copy and pasted from my first genetic testing book. And it's just a breakdown of the different genes that are in that book, and many of them. So basically, all of the toxins in our environment, they go through a handful of different detox pathways. They pretty much all funnel through the phase 1 detox pathways, which all of the phase 1 detox pathways start with CYP, and then, they go on from there, but they're all phase 1. And then there's a toxic intermediate in between phase 1 and phase 2. So the toxic intermediate is something that the body has started the process of detoxifying, and it's actually made a more toxic product in the middle of detoxifying. So this is where phase 2 has got to pick up the slack, because if you have phase 1 creating this toxic intermediate and then you don't have nice, healthy phase 2 detox pathways to finish the job, then you end up with a lot of extra toxins because you started the job and you didn't finish it up. It's like the equivalent of, I'm going to take everything out of my drawers to reorganize it, but all you end up doing is taking it out of the drawers and you don't put it back in or get rid of anything. You just make a big mess. So the toxic intermediate is the big mess that needs to be cleaned up by the phase 2 detox pathways so that your body can remove them. And, we have multiple different phase 2 detox pathways: glutathione, acetylation, methylation, glucuronidation, sulfation, amino acid conjugation. And I will talk about many of those, of course, in my limited time. I don't have time to talk about all of them. I do go through all of them in my book. So let's start with phase 1 detoxification. So this is Victor Euchenot. I used to be able to pronounce his name. Victor Yukochenik. And he was the president of Ukraine in 2014, and he was poisoned by what is assumed to be Russia. They poisoned him with dioxin, which is a very, very toxic fat-soluble carcinogen that is highly lethal. It did not immediately kill him, but the way that they actually ended up figuring it out was, so this is him before the dioxin, and then what happened was his skin started to create all of what you see on his face. He's got what kind of looks like these pustules almost, but what this is the skin, because the skin is a detox organ. Because the liver could not handle all of these toxins, the body, in its infinite wisdom, was saying, hey, we got to get rid of this stuff or else it's going to kill us. And the liver can't seem to do it. The rest of the body can't seem to do it. So we're going to push it out through the skin. And so it started creating all of these phase 1 detoxification vesicles here, which create this, lovely color here. And basically his skin started to really look awful, which was the clue that he had been poisoned by dioxin. Really, I think it was like 90 days before. Of course, his health was declining, but it was, they finally really figured out what it was when he started getting these. It was about 90 days before, 3 months before that he was exposed. So the clue was you have terrible skin eruptions that are happening, and it was dioxin. So they did give him, so dioxin is a fat-soluble toxin that you need phase 1 detox pathways to get rid of. If you don't have healthy phase 1 detox pathways, or if you just have too much dioxin to overload the phase 1 detox pathways that you have, then you're going to become very toxic in it. And so what they did was they gave him this drug, orlistat and olestra, basically to decrease the fat absorption and make it so that it would just eliminate out through his gut, so that his body would not reabsorb the dioxin, because they wanted to be able to eliminate it through the gut so that it wouldn't have to go through the liver, the kidneys, the skin, just, dump it in the toilet, which is the easiest option given the options. So he, to this day, has serious health problems and will likely have a much shorter life because of it. He has lots of liver and spleen issues even today, especially at that time. You can only imagine, that much toxins you're at, it's going to mess up your liver and your spleen and everything else. But the point is that we are all exposed to dioxin. We largely get dioxin exposure from animal fats and animal fat byproducts, which is why it's so important to try to get, organic, clean animal products, especially if it's like a fat, butter, if fatty beef, anything that is fatty animal products, try to really get quality, because the the dioxin does accumulate in the animal fat. Now, the highest exposure that most humans experience to dioxin, unless they're exposed in some awful incident like this or industrial disaster where they're burning a lot of waste, which is where dioxin is largely emitted in the environment, is from incineration of waste. But the highest exposure of dioxin is usually as a developing fetus and as a nursing infant. And a large amount of that is from breast milk, which a lot of the fat gets mobilized. So as women breastfeed, a lot of their fat gets mobilized and it gets put into the breast milk. So because dioxin is a fat-soluble chemical, our body deposits it in fat to protect it from our organs, and that's just naturally where it gravitates towards. So when you mobilize a lot of fat, as you do when you're breastfeeding, then you're mobilizing a lot of dioxin too. This is a problem. This is why women need to really work on being healthy going into pregnancy and breastfeeding. Of course, it's still important to breastfeed, but certainly we want to make sure that we have good detox pathways going into pregnancy and breastfeeding. So that's dioxin. That's the dioxin story. Okay. So phase 1 detoxification genes. I'm going to talk about just a couple, and then we'll talk about a couple of phase 2 detoxification genes. But here's an example of many of the chemicals and toxins that get detoxified through phase 1 detoxification. So lots of, you hear a lot about medications and how oftentimes people will have issues with detoxifying certain medications because of a phase 1 detox type issue. Either they're too fast or too slow to detoxify it. And it just, depends on their genetic type. But hormones, cortisol, caffeine, chemicals, drugs, Tylenol, exhaust, fumes, alpha toxins, nitrates, alcohol, and many, many more. All of it, largely starts with phase 1 before going into that toxic intermediate, and then to phase 2, and then hopefully removed from the body. So this is largely how it works. Now, the first phase 1 detox chemical we're going to talk about is, the first phase 1 detox gene we're going to talk about is involved in caffeine metabolism. So caffeine is detoxified in the liver. And some people, they do not detoxify it as quickly as others. So what this means is that the people who are poor caffeine detoxifiers, they tend to have a longer effect from drinking caffeine. So if a poor detoxifier drinks a cup of coffee and a good caffeine detoxifier drinks a cup of coffee, then the one that is poor at detoxifying, the one that's slower to detoxify caffeine, will have a longer, stronger effect from the caffeine. It's more likely to give them energy for a longer amount of time, more likely to keep them up at night, more likely to even create cardiovascular issues, which I'll talk more about in a second. So what does that mean as far as the genotype goes? Well, if you look at a genetic report that has this gene, which is RS62551 for the CYP1A2 gene, and you look and you see that they have one or more C risk alleles, then they are a poor caffeine detoxifier. If you have one, then you're worse than if you have no C alleles. And if you have two, then you're worse than if you have one C allele. So that's the genetic piece. Now, the epigenetic piece is that what if you just have a really unhealthy liver because of some other reason? Well, you can have perfect genes for the CYP1A2, but just have a lot of liver damage, and then you will not detoxify caffeine and everything else that needs to be detoxified in the liver as well as you otherwise would. And then you could have the same effect. Caffeine keeps you up at night. You tend to have more cardiovascular type reactions, rapid heart rate, high blood pressure with caffeine. So it's not just genes, it's epigenetics too. Having said that, people that have this gene, it tends to get worse with age because all of our phase 1 detox enzymes decrease their ability to detoxify as we age. That's just how it works. And depending on how good you are to your body or how bad you are to your body, that will largely affect how much or how steep of a slope of that decline is. But it doesn't matter how good you are to your body. It's a decline. It's just, it's a battle worth fighting. But at the end of the day, your phase 1 detox enzymes are going to work less efficiently when you're older than they did when you were younger, period. But like I said, it's a battle worth fighting. So this is where people who tend to have issues with detoxification, it gets worse with age. So what do I mean by this? So for example, if we look at the CYP1A2 caffeine gene, so if we're kind of just looking at the data here, the increased risk of heart attack. So if we look at the bottom here, it says, if you have 2 risk alleles, CC genotype for this gene, then these people are 36% more likely to have a heart attack if they drink 2 to 3 cups of coffee a day, and 64% more likely to have a heart attack if they drink 3 cups a day, because they're not detoxifying the caffeine. Caffeine's going to have more of a stimulatory effect to their heart. They're more likely to get AFib and die. The increased risk was the highest in women, but the risk increases with age. This is one reason people tend to have more heart attacks as they age. They don't detoxify as well. And then there's all of these chemicals that stimulate their heart, cause them to go into AFib, and then they're, more likely to have a cardiovascular event simply because they can't get these toxins out of their body. The CYP1A2 gene also helps to detoxify melatonin. So what I have found is that sometimes people will have an issue with sleeping when they drink a lot of caffeine, and they might have perfect genes as far as they don't have the genes that make them a slow caffeine detoxifier. But sometimes they'll have an issue with drinking coffee as far as their sleep, even if it's a moderate amount of coffee. And I believe part of that is because if you drink a lot of coffee, you're going to be upregulating the CYP1A2 gene, which means that you are also going to have more of the enzyme that's going to not just break down caffeine, but melatonin as well. And then you don't have as much melatonin to help you fall and stay asleep. Okay. So let's look at another CYP gene. So when you look at estrogen is really important as far as the phase 1 detox pathways, but the phase 2 detox pathways are also very important here. So estrone takes this CYP3A4, which is a phase 1 enzyme, to turn it into 16-estrogen, which is carcinogenic. And then basically it will eventually be converted into estriol. Now, the estrone will also take the CYP1B1 enzyme, phase 1 detox enzyme, to make 4-hydroxyestrogen, which is also a potent carcinogen. However, the body either methylates it, which we'll talk more about that in a second, but it will methylate it with the COMT gene to neutralize it into a form of estrogen that's not as bad, or it will take it down this peroxidation pathway, which will turn it into quinones. And if you don't have the phase 2 glutathione conjugation happening, then those quinones are going to build up and create DNA damage, and then you're more likely to get cancer, breast cancer, etc. So we've got to have the phase 2 methylation for the COMT and for the glutathione. The estrone that uses the CYP1A1 to go to the 2-hydroxy, which is more protective. Whenever everyone takes DEM, this is largely the pathway it's taking. It's largely taking the estrone down this 2-hydroxy pathway to the more protective one, which is one reason that DEM can really help to protect against high estrogen, because you're taking it towards this pathway, the 2-hydroxy, rather than the more potent estradiol, or even estrone. So that's that. Now, if we look a little closer at the CYP1AB gene, 1B1 gene, which is this one, estrone going down the CYP1B1 and then turning into 4-hydroxy and then either getting methylated to get neutralized or eventually going through glutathione to get neutralized. If we go down that pathway, let's look at a gene that can affect one's risk for health problems. For this gene, which is RS1056839, if you have a genetic report and you want to look at this gene, that's the RS number, and you look and you see what the genotype is. And if it's a G allele, then that genotype is 2 to 3 times faster than the C allele. And that can be a problem, because if you have one or more G alleles for this CYP1B1, then you're going to have an overabundance of the 4-hydroxy. So you have a faster CYP1B, you're going to have more of this potent carcinogen, which is going to potentially overwhelm your body. Now, let's say you have a fast CYP1B1. What would be a way to protect your body from this extra potent carcinogenic estrogen? Well, one way could be to divert it to this 2-hydroxy pathway with the DEM. Another way could be to load it up with methylation to make sure that you can methylate this carcinogen and ensure you have plenty of glutathione and antioxidants to get rid of these carcinogens. But the research shows that if you have this genotype, you are more likely to have more of that 4-hydroxy carcinogen, which is why it's so important to make sure that, the methylation and glutathione pathways are working effectively so that you don't get overwhelmed, and then really work to decrease overall estrogenic chemicals in one's environment. So, maybe be careful about getting extra estrogen through plastic exposure, hormone replacement, birth control, etc. Now, speaking of methylation and plastics, let's have a little refresher here. This is a study that was done to really look at methylation and epigenetics. And what they did was they got pregnant brown mice and they exposed these pregnant brown mice to BPA, which, of course, is ubiquitous in the environment and it's in plastics. And what they found was that the pregnant brown mice that were exposed to BPA, they had their offspring were obese and they were more likely to have cancer and diabetes, and they were yellow, rather than the pregnant brown mice that were exposed to BPA and given supplements to help support their methylation. The pregnant brown mice that were also exposed to BPA but were giving methylation supplements, they did not have the offspring with the yellow color. Their offspring were normal size, normal color, not at an increased risk for cancer or diabetes. And so these were, if you look at this picture down in the right corner of the actual mice, these were identical twins. They're genetically identical, different moms, but genetically identical. And basically, this is a purely epigenetic experiment. They were not playing with the genes; they were playing with the environment. And they were looking at, okay, if we expose these mice to this toxin that disrupts methylation, what's going to happen? And if we expose these mice to this toxin that's going to disrupt methylation and then give them methylating vitamins like B9 and B12 and betaine and choline, then what's going to happen? And, the proof is in the picture here. So what does this mean? That means, if you're a pregnant female and you want to have a healthy child, you better be getting those methylating vitamins, not just once you know you're pregnant, but leading up to it. So as we talk about plastic, there's a Great Pacific Garbage Patch, which is it's the largest of 5 garbage patches, and it is in the Pacific Ocean. It's more than 3 times the size of Texas, and they don't really know the size of it. So here's a picture of the Great Pacific Garbage Patch. And what's happening in this Great Pacific Garbage Patch is largely plastic is just creating these islands from the current, keeping them in these, garbage patch islands. And they're just circulating around and growing as we put more and more plastic into the environment. And what's happening is slowly this plastic is getting broken down by organisms in the ocean. And then those organisms are becoming high in plastic, and then larger organisms are eating those organisms, and then larger, fish, and then birds, and it's moving up through the food chain, and we're at the top of the food chain. And what it ultimately, the plastic that is in your brain and will be in your grandchild's brain is largely potentially coming from this Great Pacific Garbage Patch. This is what we will be bequeathing to our great-grandchildren, because it will still be there. The plastic will still be there. They may not have clean water or air or Social Security or Medicare, but they will have the Great Pacific Garbage Patch. And so we all need to do better, myself included. But here are some of the things that have been found in the Great Pacific Garbage Patch. Lots of plastic toys and whatnot. Here's a bird that died because of all of the plastics that it ate and ultimately killed it. So why am I talking about plastics and, on my soapbox about plastics? Because BPA is in plastics, and it's not just about, this bird dying or an environmental disaster. It's about these, it's about these mice. It's about these mice and not wanting to live in a world where we have a bunch of obese, unhealthy, carcinogenic children running around because their mothers did not have the methylation that they needed, but they did get exposed to BPA, because we know they're going to be exposed to BPA. There's no avoiding it. But it's really, as healthcare providers and, as people that are educated and aware, it's our job to educate people about this type of stuff. Because if it's as simple as taking a couple methylated B vitamins to help you detoxify and get those methylation pathways going, then that is a responsibility to pass that information on to potentially, help the next generation. But at the same time, we've got to do better at not just having such a ridiculous amount of plastic in our environment, because we can't give methylation B vitamins to every organism on the planet, right? So here is a visual of how our plastic growth has increased. It is increasing exponentially. It is an environmental disaster, and it's important. So let's look at the methylation cycle, because if we're going to talk about methylation and detoxification, a lot of people might not understand exactly what that means. And let's look at the methylation cycle. So I'm going to, organic chemistry here for a second. The methylation is simply where you transfer a carbon group from one molecule to another. The carbon group that gets the molecule that gets the carbon group is methylated because you add that carbon group. So if we look at the methylation cycle, and that sounds simple, but it can dramatically change the function of an enzyme. If you add that carbon group to an enzyme, it could be like turning the on switch off or the off switch on. And it just depends on what enzyme it is and what it does and how it's been methylated. So it's this huge on-off switch for the body. And the methylation cycle is really what keeps it going. And so I want to kind of talk about some of the important chemicals and enzymes here. Now, it really all starts with homocysteine. Well, it really all starts with dietary protein. So you eat protein and then it turns into methionine. You break it down into methionine, which is an amino acid, and then that methionine can become SAMe. And then SAMe is ultimately what has that methyl group to basically go and turn on genes. So SAMe goes to that COMT enzyme and gives that COMT enzyme an extra carbon group, and then the COMT enzyme can detoxify estrogen. Okay, so the methionine turns into SAMe, and then eventually that SAMe will get used up and it will turn into homocysteine. And then the homocysteine will it has a couple options. It's either going to go back through the methylation cycle and the remethylation, and it does that via the MTHFR enzyme, which requires vitamin B2. You also need the MTRR enzyme, and the MTRR, which requires vitamin B12. So you need these methyl B vitamins from MTHFR and MTRR to allow this methylation pathway to work. But you also need vitamin B2, because if you don't have vitamin B2, this methylation MTHFR gene the enzyme's not going to work. So the homocysteine can be remethylated to go back and eventually become SAMe, or it can kind of take the back door, which is the BHMT enzyme. If you have TMG, which is a TMG, then like choline, then you're going to be able to take that back door to turn homocysteine into methionine. Or the other option is the homocysteine can turn into glutathione via the transsulfuration, and you need B6 to do that. Now, these are the best options. Either you remethylate it with MTHFR and MTRR and MTR, or you go through the back door, BHMT, or you take these CBS, CTH to transsulfurate and turn the homocysteine into glutathione. Now, if none of those are working, then you're going to build up a higher level of homocysteine, which we'll talk more about what that means, a high level of homocysteine, and then you're going to end up with high homocysteine thiolactone. And so homocysteine thiolactone is a very toxic chemical that will turn, basically the homocysteine thiolactone will basically go around to the different proteins in your body and attach a homocysteine to it. And then it will denature that protein, which will make that protein not work as well, damage the tissues, create serious irreversible damage. This is bad. This is why high homocysteine is largely a problem, because it turns into homocysteine thiolactone, and then the homocysteine thiolactone goes and creates irreversible damage. Now, the body has a way to get rid of that homocysteine thiolactone, and that way is PON1. PON1 enzyme, we'll talk about the PON1 gene in a second, but the PON1 enzyme is how you get homocysteine thiolactone to turn back into homocysteine so that you can make glutathione and do the methylation cycle. And so a lot of people miss this homocysteine thiolactone piece, and it's really important because there's specific things that kind of make this PON1 enzyme work better and worse, and it's key for health. And so let's move forward. And I am going to talk more about the PON1 enzyme and gene in the cardiovascular heart webinar workshop coming up. But for the purposes of today, just understand this is an important part of the methylation pathways that doesn't get talked about a lot. So here's another visual of homocysteine either going through the methylation cycle or going into homocysteine thiolactone. And if it goes into homocysteine thiolactone, it's going to create irreversible tissue damage if it attaches the homocysteine to protein. And then if we want to get that homocysteine thiolactone out of there before it causes irreversible damage, well, then we need that PON1 enzyme, and the PON1 enzyme attaches to HDL, quote unquote, good cholesterol. And there's specific things that can help that PON1 enzyme work better. For example, quercetin, resveratrol, 5-MTHF, ECGC. These are all important, which is from green tea extract. These are all important to help increase the PON1 enzyme so that you are able to get rid of this nasty homocysteine thiolactone and turn it back into less nasty homocysteine, which can then be a useful molecule to create glutathione or, SAMe or whatever. So if you're having issues here with these methylation cycles, because maybe you have a genetic variant like MTHFR or, any of these other genes, then you are potentially not going to be methylating as well. And so, and then if you have an issue with PON1, either because you have a genetic variant that messes up your ability to make PON1 correctly or just not make enough PON1, then you're going to have issues because you're not going to be able to detoxify that homocysteine thiolactone. You're also not going to be able to detoxify organophosphates as well, like glyphosates, Roundup, pesticides, herbicides, nerve gas, and you're not going to be able to detoxify free radicals. You're going to have more oxidative stress if you have some PON1 issues, which is why it's important to not just look at methylation, but also supporting PON1, because that's a key part. And if you have a high homocysteine, maybe because you have MTHFR or you're low in B vitamins, then you are more likely to have issues with high homocysteine thiolactone. So the labs that you really want to look at are, you want to look at homocysteine. I like homocysteine to be between 6 to 8. The lab range is much larger than that. Personally, 6 to 8 is the area that I'm comfortable with and, comfortable with supplementing around. Of course, you want to look at B12 folate. I don't like B12 to be lower than 800. I think the lab range for that's ridiculous. Folate equal to or greater than 17. Of course, look at a CBC. If you're low in these B vitamins, you're going to be more likely to have a high MCV. But you have to also be careful about just taking B12 or just taking B9, because you can get a masked anemia if you just take one or the other, which is where you hide a deficiency in B12 because you're just taking folate, or you hide a deficiency in folate because you're just taking B12. And anyways, it's not good. And then really, if you're going to be supplementing for lowering homocysteine and homocysteine thiolactone, you want to make sure you have that B2, because that MTHFR enzyme needs B2, and then also you need B6 for methylation and TMG, and might as well add the extra PON1 stuff like the resveratrol, quercetin, EGCG, and then the 5-MTHF. So, and the 5-MTHF is ultimately what your body is not making if you have the MTHFR gene. So, if you have an MTHFR gene, you're not going to be taking folate from your diet, from eating green vegetables and converting it into the methyl activated 5-MTHF, simply because you have that gene, and then that's going to create more of a buildup of homocysteine. And that's why people that have MTHFR really need to consider supplementing with methylfolate. So again, the homocysteine range I'm comfortable with 6 to 8. Other doctors are comfortable with different ranges. That's just the one I'm comfortable with. But there are many diseases associated with high homocysteine and high homocysteine thiolactone. And, it can range from Alzheimer's, birth defects, miscarriages to, osteoporosis. Many of these same diseases are also associated with MTHFR. That's because MTHFR creates high homocysteine, and high homocysteine creates high homocysteine thiolactone. Again, MTHFR issues, this is an important methylation detox pathway. It varies from stroke, diabetes, multiple sclerosis, all the way to schizophrenia, inflammation, autism, osteoporosis, reproductive issues, miscarriages, fibromyalgia, pregnancy complications, celiac, just lots of different issues related to MTHFR. Here are the MTHFR genes. There's two. They're both significant. The C677T is more significant for cardiovascular. You're going to see a higher rate of cardiovascular and high homocysteine with the C677T, especially if you're homozygous. The A1298C, you could see a high homocysteine, but this is probably more like neurological, but still both of them are treated the same way, which is the methyl B vitamins. Make sure you have the methyl B2 as well. So if we talk about glutathione, which is we're going to talk about phase 2 for a minute here. So glutathione is a really important phase 2 detox pathway. So glutathione either can conjugate to bind to toxins and remove those toxins with the glutathione S transferase enzyme, or it can go through the pathway of glutathione peroxidase, which will help to get rid of free radicals like hydrogen peroxide. And then that glutathione peroxide, it needs selenium so that then the glutathione can turn the hydrogen peroxide into water and then hopefully get recycled back around. Once you turn the hydrogen peroxide into water, then you have to recycle that glutathione peroxide by using vitamin B3 and B2 and even vitamin C and help bring it back around so that you have reduced glutathione to either go through the glutathione peroxidase pathway again or go to the glutathione S transferase pathway, which is where it binds to toxins like hormones and various toxins in the environment and helps conjugate them out so that you can eliminate them rather than, just store them in your body. So glutathione S transferase, again, this is where you get rid of heavy metals, toxic chemicals, hormones, phase 1 intermediates, xenobiotics. And these are some of the genes: GSTM1, GSTM3, GSTP1, GSTM5. These are some of the important glutathione genes that have to do with the glutathione S transfers, the glutathione S transferase, and they're all going to start with GST because GST stands for glutathione S transferase. So the glutathione, via this enzyme, glutathione S transferase enzyme, is going to bind to the toxin and excrete it. Here are some of the important glutathione S transferase genes. One of the most important, they are all important, one of the most important that I'm going to talk about here for a second is this first GSTM1, RS3666631. And if you have two T allele risk alleles, you have the null genotype, which will decrease the glutathione S transferase activity, alter estrogen synthesis and metabolism, increase risk for cancer, largely because of a decreased ability to detoxify, because you have a deletion in this gene, which is going to change the way the glutathione S transferase enzyme works and functions and looks, and that creates real changes in the body. So some of the research shows that what that could look like is increased risk for cancer because you cannot detoxify as well. So other research would show having decreased ability to detoxify heavy metals, more lipid peroxides. Lipid peroxides are going to increase your risk for ferroptosis, which is iron-induced cell death, decreased ability to detoxify herbicides, fungicides, increased risk for asthma. It's really important to have lots of glutathione for your lungs, increased risk for lung cancer and cancer in general, increased risk for Alzheimer's. The brain needs glutathione, your whole body needs glutathione, and some of these people just don't make as much or, detoxify as well. Then we have glutathione peroxidase. So this is basically, you start out with the superoxide free radicals, and then the superoxide free radicals goes into the SOD2 enzyme gene, which binds to manganese, and then that turns it into hydrogen peroxide, which is bad. But then we have glutathione peroxidase, which comes and saves the day. It has selenium, and it turns that nasty hydrogen peroxide into water. If it does not work, and we have all this extra hydrogen peroxide, what are we going to get? we're going to get free radicals. So again, dangerous superoxide free radical, SOD2 gene enzyme, hydrogen peroxide, glutathione, and catalase, which are other important genes I'm not talking about today, but are in my book, the genetic testing book, help detoxify and turn this stuff into water and oxygen. Here's some of the important glutathione peroxidase genes. If you have a genetic report, you can look at them and understand, what your genes are and what you can do about them. And it largely comes down to decrease in oxidative stress. So you're going to have to increase glutathione, increase antioxidants. And here are some of the health implications of some of these glutathione peroxidase genes. Now, there's lots of different issues. It could be increased tissue damage from free radicals, lung problems, eye problems, anemias, and more ferroptosis. Okay. So people that have high iron, which I, am writing a book about iron. It'll be out soon. It's called The Iron Curse. People that have the glutathione peroxidase genes, they're going to be more likely to have issues with ferroptosis, which ferroptosis is where you basically have lots of iron and hydrogen peroxide and polyunsaturated fats, and it creates free radicals, which create lipid peroxides. It reacts with the cell membrane, and then the cell kills itself via ferroptosis. If you have lots of glutathione peroxidase and have good glutathione genes, then you're not going to have as much ferroptosis. But you need those antioxidants. You need the glutathione. Otherwise, you're going to have ferroptosis, which is going to destroy your liver, among many other things. So epigenetic support for glutathione, avoid alcohol, avoid Tylenol, heavy metals, avoid smoking, avoid toxins. All that's going to deplete and tank your glutathione. You want more glutathione? NAC, selenium, milk thistle, vitamin C, vitamin E, N-acetyl glutathione, alpha lipoic acid, B vitamins, sulfur-rich foods rich in cysteine, broccoli, Brussels sprouts, etc., glucoraphan and resveratrol, vitamin D. All of these support more glutathione. I don't have a ton of time, but I'm just going to introduce you to some alcohol detox genes, and then we'll be done. So there's two big alcohol detox genes. There's basically when you consume alcohol, the alcohol will get converted into this really toxic acetaldehyde by this ADH1B gene. And then that toxic acetaldehyde, and this is what gives you the hangover. The toxic acetaldehyde will get converted into acetate, which is when you're no longer have a hangover and you're recovered by this gene ALDH2. So you consume alcohol, turns into ethanol. Ethanol gives you, that drunken, happy-go-lucky, you're inebriated feeling. And then the ADH1B gene turns it into this nasty acetaldehyde, and then you have a hangover and you hate alcohol for a minute. And then ALDH2 comes to save the day, and you recover, and, maybe you're ready to go drink again, maybe not. So these are the genes that can affect the ability to turn this ethanol into the acetaldehyde. Some of them convert it faster. Those people tend to have less fun drinking alcohol because they quickly go from inebriated to hungover. But the people who really have problems are the people that have issues with this ALDH2 gene. And this is a big one, this ALDH2 gene, because they don't detoxify the acetaldehyde very well, and that toxin sits around, and they're more likely to flush, turn red. This is called the oriental flush. It's a very common gene in Asia. It's a mitochondrial gene that's passed down maternally. And so, but lots of issues with increased risk for esophageal cancer, neurodegenerative issues, lightheadedness, heart palpitations, nausea, inflammation, liver issues, hangovers, and it's all alcohol related. If you don't want issues and you have this gene, if you just don't want issues with alcohol, don't drink alcohol. It's pretty easy. That's really these people that have this ALDH2 gene, the A risk allele, they really need to not drink alcohol. That's the easiest solution to that. So whether you have bad genes or good genes, your environment can ultimately decide your fate. It's really more so as much about the choices you make. There's not a lot of shortcuts in health, but I think I just gave you maybe a couple. So if you use those smart, if you act, work smarter, not harder, then maybe you can avoid some genetic landmines. And certainly the sooner you know about genetic landmines, the more you can do to prevent developing a disease. So thank you for your time. I know I, went over a little bit, but I'd love to connect. If you want to reach out to me on Facebook or Instagram or YouTube, here's my stuff. And then I do have my first genetic testing book that was been published years ago, and then my upcoming Iron Curse book. High iron can destroy the liver and decrease the ability to detoxify. I do talk about that in the book, and even some other workshops with systemic formulas. Just keep that in mind. I, can't in my workshop without mentioning how iron can destroy the liver and decrease your ability to detoxify. So thank you for your time. I hope you learned some things and that's helpful. And I hope to see you at the next Systemic Formulas workshop.